All right, we are in Chapter 1, Lesson 3 or Section 3 for Math 8. And we're going to start going through the idea of monomials and also kind of simplifying some exponential problems here. So the very first thing they have us go through is the notes just identifying what a monomial is. So this is one of those things that I learned this way back in high school, but root words can definitely help us understand what a word means. So if I hear nomial, I know this means number. So this, no matter when, if I hear the word nomial, I know it means number. Mono, which they kind of squish these two together because they both have an O on them, so they're not going to go monomial. That sounds funny. But we just smush them together and say monomial. But mono means one. So monomial means one number. And there's other ones we'll come to eventually. We might hear binomial. So bi, just like in bicycle with two tires, bi means two. So we'd have two numbers because there's monomial in the end. And then if we hear, I don't know if we'll get this far in Math 8, but we may hear it, trinomial, just like if we think of a triangle or a tricycle. So triangle has three corners, tricycle has three wheels. So tri means three. And monomial means number, so three numbers. So it's one of those ways we can identify what they mean by using the root words here. So in these notes area, we just want to identify what a monomial can be. So it can be just a number. So any number, I can pick 1, I can pick 20, I can pick 1,000, a number. It doesn't matter what the number is, any number. This is just 3 examples of infinite examples. There is any number that you want to choose can be a monomial. You could also have a variable. So any number or any variable, so it can be X, Y, A, doesn't matter what it is. And remember, a variable is just a placeholder. We just don't know what that number is yet, but it's holding a place for a number. So instead of just using a blank area, we just use X or Y or A or whatever letter we feel like using. Okay, so it's just a placeholder. Or it can be a product of a number and one or more variables. Sorry, I'm going to stick that on the end there. Unless I'm spelling variables very wrong. Variables. There we go. And product, this means to multiply. Okay, so we can multiply a number and a variable or more than one variable. So I can have a number, so I'm going to choose 20 from up here, and one of my variables, x. When I squish them together like this, it means 20 times x. Or more than one variable, so I can have what we call exponents, which we practiced in the last one. So I have squared, this means 2 x's. Or I could even have x times one of my other variables up here, which is y, like that. So there's a couple of different options for this one. The main idea is that it's either a number or a variable by themselves, or it's a product. It has to be multiplication. If we're adding in addition or subtraction, that means we have more than one number. Remember, we're only looking for one number. So once we add 2 pieces together, now we have 2 numbers or possibly 3 numbers, if we get that far. So we don't want any addition or subtraction. And division we have to be careful about. We can't divide by a variable because now we're changing that one number idea. And I'll explain that on the examples down below here. So if we look at these, it says circle the expressions that are monomials. So we have 15 times 15. That's what 15 squared means. So it's a number times a number. So I'm using product. I'm using multiply. So this one is perfectly fine because I can actually work out 15 times 15 and I have my one number. X plus 6. So this is not a monomial because I have a plus sign here. Now I have one number, that's x, and I have another number, which is 6. So I have 2 monomials here that are being added together, and this is what we call a binomial because it's 2 numbers. So same thing with this third example. I have a minus sign here. So that means I have one monomial here. 2 times y squared is a monomial. And 3z is also a monomial. But when I combine them and I put them together, I'm trying to subtract. Now again, I have 2 numbers in this expression. So we call this a binomial, not a monomial. All right, this one I have 4 times a times c. So it's a product of a number and one or more variables. This fits exactly into that third definition there. So this guy definitely works. I'm only multiplying those numbers. 47, so this is just a number. This is the very first thing that we came across here. That was our first definition, or our first bullet point there. And then we have 6n on the end. So we can't, this is when we have to be careful. If I had n over 6, this would be perfectly fine. Because this is actually means n divided by 6, which we can write as 1/6 times n. So it's still multiplication there. I'm multiplying n by 1/6. So this would have been perfectly fine. But once we start dividing by n, or any variable, we're changing that idea. So now we go back to having more than one number, kind of. It doesn't fully fit like it does with the plus or minus, but we can't divide by a variable. So if you see a variable in the denominator, in the bottom, it is not going to work. And the reasoning is because of that variable. All right, so let's go ahead and look at this second notes feature here. We have blank, blank, blank means to multiply powers with the same base and their exponents. So we know we're multiplying, which we tend to call a product. Oops. I didn't mean to click on show there. There we go. Oh, no, that was not what I wanted to click on. That's what I wanted to click on. Okay, sorry. Jumped to the other one because I accidentally clicked show instead of close. So we know we're multiplying. And we're going to be talking about powers. So for the next couple sections, we're actually going to be doing quite a few of the power rules. So in this case, we call this a product of power. So remember, a power, this is a power. 3 to the second power. The whole thing together, we call that a power. 3 is the base, 2 is the exponent, but the whole thing we call a power. So product of a power means that I'm multiplying 2 powers with the same base, so they both have a 3 in this case, and their exponents get added together. We actually built this on the previous section, so we kind of built this rule. We thought ahead about it. So in this case, they're showing us the breakdown. I have 2 3s for this first one, because that's 3 squared, and then I have 4 3s for the second one. Well, they're all being multiplied. If I can change this one to 3 squared, because there's 2 3s, and I can change this one to 3 to the 4th power, because there's 4, why can't I just add them all together and write 3 to the 6th power? Well, the answer is you can. So the idea here is that we want to combine the exponents, as long as it's the same base. You can't have different bases and do this, perform this operation. It has to be the same exact base, and then you say 2 plus 4, and you get 6. All right, so we're going to go ahead and look at these down here. Let me scooch down a little bit. Okay, so we'll go ahead and expand the first one here just so we can see it expanded. So we have 9 to the 3rd power. Sorry, no, that's a little blurry. 9 to the 3rd power, that means 3 9s, not 9 times 3, 3 9s. And now I have 9 squared. So I'm going to do this one a little bigger so it shows like that was the one that was already there. And then here are my... So I have 9 cubed and I have 9 squared. So how many 9s do I have altogether? 5. So 9 to the 5th power. So again, I had 3 here, I had 2 here. I'm just adding how many I have. 3 plus 2 is 5. And this is what they want us to write down here. All right, so without expanding this one, I want to do the same thing, but I'm going to look at it. I have the same base, a and a, so I know I'm going to have a. And then I'm just going to look at the exponents. I have 3 here and 2 here. If I add them together, I get 5. So that's going to be my new exponent, a to the 5th power. All right, this one's a little different because now we have coefficients, which means these numbers. I have a -2 and I have a -8. Coefficient's a number in front of the variable. That's what we call that number, is a coefficient. So now I want to do -2 times -8, and then m times m to the 5th power. So I kind of separate them out here just so that you can see. You're going to multiply the coefficients, the numbers, and then deal with the variables and the exponents. So negative 2 times negative 8, 2 negatives make a positive, and then 2 times 8 is 16. And then with this one, if you don't see the variable, it means you have one of them. Sorry, not the variable. If you don't see the exponent, it means you have 1. So I have 1m, I have 5 m's. Since they're both m, I can add them together and I get 6. So I'm going to have m to the 6th power. I don't have to put the dots in here. I just did the parentheses and the dots to kind of expand it out and show you. But when you write this all together, this means 16 times m to the 6th power. I don't have to put the dot in there to know that it's multiplication. If they're squished together like that, it means multiplication. All right, let's go to the second page here because this is also, I believe, for section 3. Yes. All right. So the second one, we have blank, blank, blank means to divide powers with the same base and then subtract their exponents is what we do. So in the last one, we were adding the exponents because we were multiplying. So addition, multiplication, they both make something, they make the answer or the solution go up. This case, we're going to divide and subtract. So they both are decreasing. So hopefully we can make that connection. That's a little easier. And so this is going to be of product or of powers, but now we want the word quotient. Quotient. And what that means is to divide. That's one of our key words that means division. So quotient of powers. So quotient is the answer to a division problem. So that's definitely a word we should know, and we should, if we don't know it, we should practice it, make sure we memorize it. Quotient is important. So product means multiplication, quotient means division. All right, so let's look at this example here. We have 5 to the 7th power divided by 5 to the 4th power. And then they expand it out here. So they show us the 7 factors on the top, because there's 7 5s, and then they show us the 4 factors on the bottom. So here's 4 5s. And if you notice, they're crossing them off. And what they're doing is they're saying, this one matches, here's another one that matches, third one that matches, and a fourth one that matches. Now I don't have anything else to cross off. So my answer is what's left over, which is 5 to the 3rd power. I have 3 5s left. Okay, so this is just a visual for doing that. But we can also take it and use subtraction. I can say there's 7 on the top, there's 4 on the bottom. If I subtract, I will have 3 left. So that gets us the same exponent here, 5 to the 3rd power. So we'll look at it kind of both ways there, just so that we can see the difference. So this first one is this exact answer here. So I'm just going to go ahead and write the answer here, and we're going to move to the next one because that's exactly the same example. So we have x to the 10th power and x to the 3rd power. So we're already starting to get to that point where it's a little tedious to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the bottom, I have 1, 2, 3. So I've expanded this out. Here's my 10 x's. Here's my 3 x's. And I can go through and I can cross them off as I have 1 to 1. Here's another 1 to another 1. Another 1 to another 1. So now I have these 7 left over. So I have x, that's my base, and I have 7 of them left over. But again, if I just did 10 minus 3, I'd also have 7. So if we look at this, now we have a coefficient on this one, meaning the numbers on the front. So I have to do 12 divided by 2. So I have to kind of separate these out so that I can see. It's 12 divided by 2, which gets me 6. And then w to the 5th power and w to the 1st power. Remember, if we don't see the 1, it means we have 1. So if we do 5 minus 1, I get 4. So this is going to be w to the 4th power. So I know I'm kind of scrunching that all together there, but I'll circle it so you can see that. So make sure if you're doing multiplication or division, it doesn't matter which one you're doing, if you have coefficients, you have to multiply or divide those coefficients first. And again, coefficient just means that number in front of the variable. And then you can deal with these variables and exponents. All right, let's take a look at these ones. Yes, they're starting to look a little bit more complicated, but we just go piece by piece. So I have my bases of 3. You need to make sure you match up your bases. If they're out of order, it's not a big deal if they're out of order. You just need to make sure you match them up. If for some reason this 3 squared was on the end, wouldn't change how I did it. I just need to make sure that I'm looking at those two together. In this case, they're lining them up all nicely for us. So 3 to 3, I have 4 minus 2. 4 minus 2 is 2. So I know if I go through and I expand it and I cross them off, I'd only have 2 left. Now I have 5 squared and then 5. Remember, this is 2 and 1. 2 minus 1 is 1. So I have just 5. And then if I do, I wanted to make sure, if I do this one, 5 minus 3, I'd get 2. Sorry, 7. Base of 7, I forgot to say that out loud. Base of 7, 5 minus 3 is 2. And you can, I want to say that we can leave it this way. I believe. Although it is showing me an OR option. So that's definitely, we can go through and we can multiply this out. So this one was showing me the OR option. I just noticed that. We could say 5 to the 3rd power, or 5 times 5 times 5 is 125. Either one of these is an acceptable answer. And then with this one, we'd have 3 times 3. So we get 9 times 5, because that doesn't have an exponent. And then 7 squared, we get 49. And if I scooch this up a little bit so I have more room, I'd have 9 times 5, which gets me 45, times 49. So we might be getting in the realm here where we're going to have to write this out or maybe use a calculator. So we'd go 45 times 49, and we would get 2,205. So again, I'm not sure that Alex would accept this one because it's not quite simplified. It might actually be looking for the 2,205. But we did go through and give it all positive exponents as well. So that is simplified. All right, so with this one, we have 5 and 5. So 6 minus 4, that gets us 2. And then we have 7 and 7. So 4 minus 2 gets us 2. And then 8 and 8, 3 minus 2 gets us 1. So now we'd have 25. 5 squared is 25. 7 squared is still 49, just like it was in this problem over here, and times 8. So if we multiply all these together, we have 25 times 49 times 8. We end up with a pretty decently sized number here, 9,800. So this is just completely simplified down to one number. All right, so now we're going to do this one. I'm going to do this one off to the side here just so I have more room. -2 and -2, that's our base. Even though it's in parentheses, it's not really changing anything. It's just showing you that -2 is actually what we're multiplying here. So we'd have -2 in parentheses. We want to keep that like that. We have 5 minus 2, so we get 3. Times 3 and 3. So 4 minus 1 is 3. And then 5 and 5, so our base is 5. 7 minus 4 is 3. So they all end up with an exponent of 3. In this one, be careful when you're multiplying this. It's not just 2 times 2 times 2. It's -2 times -2 times -2. So it actually ends up being -8. You just have to be careful when it's in parentheses like that. It's including the negative sign. Times, and then 3 times 3 times 3. 3 times 3 would be 9. Times 3 more would give you 27. And then we did 5 cubed already. That was that first one, so I'm just going to go ahead and steal that number. And now we can go ahead and put these in. And I wanted to show you, you can actually do this on a calculator. I'm going to close that real quick. All right, so when I do this on a calculator, if I go 8, and you should find this little button. It might be in different places depending on the calculator you're using, but you should see something along these lines. Might even have little arrows going from one to the other. What it means is I want to make it negative. So I can go -8 times, and it would help if I remembered my numbers here, 27 and 125. 27 times 125. So this will give me the whole number. I just need to make sure I put my comma in here when I'm answering the question. So negative 27,000. Okay. So now we're going to do this one, and this was a kind of going back. This is a practice for multiplication because now we're multiplying these pieces. So we want to make sure we're multiplying them basically by kind of like terms. So coefficients, I have negative 7 and I have 5. And then I have A and A. So I have A to the fourth and A, just A, times, now I have just B times B to the fourth. And then I have C cubed and C squared. So all I did was I rearranged it so they're together, so they match. So coefficient to coefficient, A to A, B to B, C to C. So now I can start combining. Negative 7 times 5 gives me negative 35. And then here I have A and A, so I know it's the base of A. And I have 4 plus 1. This is multiplication now, so we're adding these. We only subtract when it's division. So we're kind of going back and repracticing some multiplication. B to the first power plus B to the fourth power. So this is B again, but I'm just going to add 1 and 4 for the number of exponents. And then C to the third and C squared. So it's 3 plus 2, and that gives me 5. So they all end up being 5s by chance in that one. All right. Oop. Scooch down here. Okay. So let's go ahead and practice this. These last two pieces here. We have 16 divided by 8. So remember, separate them out. 16 divided by 8. And then my variable. So 16 divided by 8 is 2. Because that can divide evenly. And now I'm dividing, so I'm going back to the subtraction rule. We've been practicing this whole time with the exception of number 3 here. So it's 4 minus 1 t to the third power. Because 4 minus 1 is 3. That means I have 3t left over once I apply that rule. All right, so now in this one, we're just doing kind of the same thing we were doing up here, just with we're going back to exponents. So we have x to the 6th power, x to the 4th power. 6 minus 4 is 2. And now I have y to the 14th power, y to the 9th power. 14 minus 9 is 5. All right, so I believe that will be it. Yep, that is it for section 3. So I will see you in section 4.